Welcome. I'm Naomi Gerstel, a board member of Northampton Neighbors and chair of the Speakers Committee. First, I'm going to tell you just a little bit about Northampton Neighbors. Then I'm going to talk a little bit about the logistics for today, and then talk a little bit about Bob and Leverett, and then we're on to the main event. Northampton Neighbors began about 5 years ago to welcome people aged 55 and older to stay in their own homes and apartments and lead full lives. We are part of an international movement of villages, as we are called. Our group, Northampton Neighbors, now has about 1,400 members. We provide many services, volunteer activities, and other ways to connect people in your community. We welcome you to all of those events. They're listed on our website. And we would love to have you volunteer. Join if you haven't, and volunteer. We are free. We're one of the few villages that are free. Everybody can join. Now the logistics. Bob will talk for about 25 to 35 minutes, and then respond to your questions. We use chat for questions. You'll see it at the bottom of your screen. All you have to do is tap on chat button and press enter to make sure that your question goes through. We prefer that people wait until the speaker's finished, because he might answer the questions you have. And we see the chats, but if you can't wait or you're afraid you'll forget, please enter it. All our mics are muted by our tech wizard, Nina Kleinberg. If you want to read along, just click CC at the bottom of your screen and you'll see a transcript as people are talking. It's a pretty amazing thing. And the final thing is, this event is being recorded. If you don't want to show up in the recording, just turn off your camera. And if you want to hear it again or recommend it to your friends, just go to YouTube, which you can go through Northampton Neighbors, or directly through YouTube if you type in Northampton Neighbors. And you can also see it on Northampton Open Media. So now let me say a few words about our star attraction, Bob Leverett. We are honored to have Bob. He was educated as an engineer. He's the author of scores of essays, articles, and books, and has taken people on thousands of tours of old growth forests. He is known as the old growth evangelist, who rediscovered old growth trees in Massachusetts that many ecologists just thought were gone. And he developed practices to precisely measure, innovative practices to precisely measure the height of these incredibly tall trees. When we thought about inviting him to speak, one of his recommenders, who had been on one of his tours and heard him speak, said he's a gem. Put it simply, he's a gem. There's also was just an article about him in the Smithsonian magazine entitled "The Old Man and the Tree" that you can see on the announcement we sent out. Just click on that, or just go to Google and type in Leverett and Guggenheim, and you will see, Smithsonian, and you will see the article. It'll appear on your screen. So I thought I would conclude with a quote from that article. Let me just read it to you. It's a wonderful article. Over the decades, Leverett's work has made him a legend among big tree hunters. He comes across like something between an old Southern senator and an itinerant preacher. Invariably, the topic of these sermons is the importance of old growth forests, not only for its serene effect on the human soul, for its biodiversity, but for its vital role in mitigating climate change. So it is my great honor to introduce Bob Leverett, our neighbor. Take it away.
Okay, screen share. Thank you all, first of all, for joining me. I'm going to be talking about a great passion of mine. And let me, first of all, say that in terms of the evangelist title, maybe I come by it legitimately or honestly. My maternal grandfather was a circuit riding Baptist preacher in the Appalachian Mountains. And my dear wife, Monica, here says, Bob, you definitely inherited the gene. So getting up and in front of groups and preaching of some sort seems to come natural. At any rate, thank you, Naomi, for the introduction. And I just put a few of the titles that I've collected along the way. and give you a moment to just quickly look at that. I hope that gives me an introduction that will make what follows fit. So without further ado, I'm going to go to the first slide, and there I am in Massachusetts old growth that wasn't supposed to be here. When I first started finding old growth forests, I was relying on my background or as having grown up in the shadows of the Great Smoky Mountains in eastern Tennessee and western North Carolina, and being aware what we then called virgin forest looked like. And when I left the U.S. Air Force and moved to Massachusetts, I like to say that as a Southerner, I left the Air Force, and instead of flying south, I got turned around and flew north. At any rate, I landed in Massachusetts and was the first vice president and the president of a management consulting firm. And as an engineer by education and in the Air Force, it didn't seem to make much sense how I would be involved with old growth forests. But I've never not been involved with forests. They always formed a natural underpinning for me. And wherever I was around the world, I always sought out the forests. So when I started looking around Massachusetts, I actually was getting my legs in condition to climb mountains in Colorado. So I would go out into the Berkshires and I'd go into the steeper ravines, and I started seeing trees and areas that looked remarkably similar to what I was accustomed to in the Southern Appalachians, in areas that were absolutely known as virgin or old growth. And so I started asking questions. And after a period of time, I wrote an article for the Mass Forestry Association's Woodland Steward about old growth forests in the Deerfield and Coal River gorges. And my phone started ringing off the hook. And these erudite scholars that had been studying forest from one perspective or another, either forestry or forest science, say, "Are you really finding old growth?" And I was careful enough to say, "Well, I don't know, but I'd like to show you. Would you come out and take a look at it with me?" And they did. And I was myself and Tad Zebrick, who was getting a master's degree at Harvard Forest at the time. We were up in on the side of Mount Everett above the Berkshire School, and there's a waterfall up there, and the hemlocks in that area were old growth. I knew that. I could see that. We were up there, and Tad had an increment bore, and I said, "Tad, I think if you core that tree over there, it's going to be," and then I hum-hawed a little, and I said, "maybe 330 years old." Well, he took a core out, and he did a field count, and that's a little risky, but as chances would have it, it came out to 330 years. Oh, my stock just went out the ceiling. Suddenly, yesterday I couldn't spell it, and today I are one, was the kind of thing. So from there, I got other people involved with me, and we started mapping out old growth forest remnants in Massachusetts and came up with about 1,200, 1,300, maybe by now 1,400 acres. And what you're looking at is one of those places. This was a huge white ash, Fraxinus americana. It's now fallen, unfortunately, but it was the largest in-forest, forest-grown ash, white ash, that I had seen anywhere in New England. And so it, in time, was photographed many times, but it really said, "Oh, you know, this is Massachusetts. This is not what we think of as 1850s, 1840s, mostly cleared Massachusetts. How did this survive?" And the answer was simple. It was on a boulder field. If you tried to take a horse or an oxen up on that boulder field, it'd break a leg. So there were places that were simply left. They were called inaccessible, and this is one of them. From there, let me go to another place. Along the way, I found that the largest concentration of old growth forests in our state is in Mohawk Trail State Forest. And on Todd Mountain and Clark Mountain, that complex there. There was the largest single area of old growth, and there were other places, Mohawk Trail. So altogether, Mohawk turns out to have about 45% of all of the old growth in the state. Well, what does it look like? Well, how did I know? Well, because I've been seeing it, or I grew up with it, looking at it in the Southern Appalachians. Well, here's a picture of what it looks like on that boulder field. What you see in the center of the picture is about a 200, probably closer to 250-year-old sugar maple. And over to the right, you see that fork tree, and that's a yellow birch. And to the left of it, you'll see other species. I'll point right there. That's black birch. And these trees were uniformly above 200 years. But later on, my good friend Tony D'Amato, who's he is the director of the forestry program for the University of Vermont, he actually cored a black birch on that same boulder field not far from where that picture was taken. Is 332 years old. It was about the 7th oldest that we knew of anywhere in the country, anywhere. And he also cored a hemlock it's now over 500 years old. Well, all of a sudden, we didn't just have old growth, we had Class A old growth, yet it was in these very inaccessible places. And it didn't necessarily look the way some people might think old growth would look like. So I started, as we found more and more places, thinking about, well, how can I explain this? How can we portray what old growth is supposed to look like? It's not all uniform. For instance, here's old growth. On the right, you see a picture of, not far from the picture on the previous slide, and you see a down log. This was a sugar maple in an advanced stage of decay, but every place around you'll see boulders. And then you can see in a more microscopic form, here's a yellow birch, and here's a new root system coming out. All of this really spoke to complexity. What we see in old growth forests, natural forests, it's not a biological desert as some people once thought. It's very structurally complex and very diverse. And therefore, what we get are a lot of niches for wildlife, for plant life. And that was one of the great discoveries. Well, I wouldn't say it was a discovery, it was great confirmations that came along, that the more we studied the old growth, the more complex that it got. And that led to a lot of later discoveries and research, such as in Suzanne Simard's work in the Pacific Northwest in British Columbia, where what it turns out that what's below ground is even more complicated or complex than what's above ground. Well, let me go to but just think of what you're looking at for a moment. Lots of roots, lots of down woody material on the forest floor, lots of complexity. Now let's go look at a different one. Now this is old growth too. Where is it? It's on, it used to be the Metacomet Trail, but now I think it's called the New England Trail on Mount Tom. And you're looking through 200-year-old red pines that have no real commercial value, and they were left. And so you have cliffside old growth forest. It can look like that. And the trees are stunted, or at least they're not large. And so you can't generalize about what old growth looks like in terms of thinking of it as just large. It's not uniformly old. Old growth is really a misnomer because you have all ages in there. But again, the sweep of the ecosystem features makes it very interesting to study. And that's what we were doing. Now, old growth is in a lot of places. And it wasn't that we didn't know about a lot of these places, but they didn't get they didn't get spread that much. Now with the internet, you can find them. For instance, one of the great places to see old growth is over in Pennsylvania in a place called Cook Forest State Park. Very rich history. What you're looking at there on the left is a hemlock, an eastern hemlock, and these are the branches of a white oak. about a 250-year-old white oak. All different hardwoods, softwoods, or conifers, all mixed in together, and all creating an ecosystem with lots of dependent life forms. Well, let's see. Let's go on to another one. A lot of old growth forests do have the appearance of being large or having large trees. This is a 350-year-old hemlock, and back of it is a soaring white pine. And this is in a place over in Western Pennsylvania called Heart's Content. And this is one of those iconic old growth sites. You can visit it. That was written about in books on forestry, books on forest ecology. So a lot of people went and visited that. And so a lot of the early descriptions of eastern old growth forests were based upon just a few sites, this being one of them. This is a great place. And I've measured lots of trees in there. We've measured white pines up to 167 feet in height. But it was basically a white pine forest. Now it's more hemlock than and hardwoods than white pine, because as the white pines die, the other species that are able to exist in lower levels of light come in the understory, and the whole forest changes. So this is one of those places where you can't say old growth is just a set number of range of species, and whatever it looks like now, that's what it's going to look like in the future. Not at all true. Let's go back to Massachusetts. Here's another little jewel that we found in Monroe State Forest, very close to the Vermont border. And this was dominated by hemlocks and red spruce. But there were many, many, many seedlings and saplings on the forest floor. A lot of people thought of old growth forests as being botanical deserts. Nothing could be further than the truth. But in this case, I think probably 300 years ago, something like that, maybe even less, there was probably a major wind event, maybe, I don't know, a hurricane or whatever, and it blew just about everything down, and you had this rich ground layer of logs, and they begin to decay, and on them seeded little hemlocks. And today we've got this second generation of old growth. Very, Monica loves, my wife Monica, she loves this place. And I don't remember, what do you call it, hon?
The magic forest.
The magic forest. It's her magic forest. Let's go to another one. Well, hop, skip, and jump. Let's go back over into New York, or not back over, but over into New York. This is near Warrensburg, New York, in a place called Packed Forest, and you can visit there. And this is one of those great sites that had huge white pines in the past, and now it's reverting to hemlocks, yellow birches, and sugar maples, and other species like that. But the big pines are still there, and you can walk. And the first thing you see is it's messy. The forest floor is cluttered, but that clutter is very important. It creates niches. It creates habitat for many species, both plants and animals. This is just simply one of my favorite places. This is in Packed Forest, and that's a younger me standing between two of the big white pines. Those trees right there are around 300 years old. And white pines can go to even 400 years, but more often they live, their longevity is between 250 and 350 years. So we're looking at the tail end of the white pine stand that would have once been almost pure stands, pure white pine stands. I was actually up there at that time with some people from National Geographic, and they were taking photographs, and I had all my measuring gear on. You can see there's a Nikon, and there's a laser measuring devices. And as an engineer, I have to measure. It's in my genes. If something will stand still, I'll measure it. In the military, we had this saying that if something moved, you saluted it, and if it stood still, you painted it. Well, I measured it. Next one. Here is back into Massachusetts. Well, now this isn't old growth, but it's on the way to becoming that. And it gives us a history of a forest not in transition, but still mainly white pines. This forest here probably started around a few years before William Cullen Bryant passed on. He might have seen those white pines as seedlings. Today they're giants. And one of the reasons that this particular forest, which I'll say a lot more about, is very important is because it is a sink for carbon. There is an enormous amount of carbon tied up in this forest. And one of the things we do is quantify that. We measure both standing and on the ground, and other people, I don't, go below ground and measure the amount of carbon below ground. And these older forests are the ones that hold the most. So they are, and they're still accumulating carbon. So they're very important in terms of climate mitigation. If you cut them down and you lose that, you aren't helping the climate at all. So whatever we have in terms of these old forests, we really want to hold on to. Let's move on. Another look at the Bryant Homestead. And the trail through here, incidentally, for the trustees, I actually laid out for them, working with some Smith College students. And you can see a trail marker right there. Well, when I originally went through to mark the trail, we put flags around different trees. And when Jim Caffrey, the forester there, went through, he was going to straighten the trail, make the trail mark it. And he told me, he said, Bob, I was trying to follow your pathway, but I couldn't figure out what was happening. I thought the trail was going to go this way, and all of a sudden it would go that way. Well, I was just running from one big tree, yelling and hugging it, and didn't have too much of a plan. So he straightened out the trail, and it's really his trail, but it was us originally laying a pathway out. Now, going on, I'd like to mention that William Cullen Bryant was an iconic individual. He was extremely important as an abolitionist, as a poet laureate, as he was a homeopathic practitioner of homeopathic medicine. Oh yes, and as Monica points out, the editor of the New York Post. Bryant Park in New York is named for this William Cullen Bryant. And he grew up in Cummington, Massachusetts. And he always thought that he had virgin forest on his property, and by golly, he did. Now you're looking at a trail called the Rivulet Trail that goes through. These hemlocks here are not conspicuously old. They're about 220, 230, 240 years old. There are some over 300 in there, and maybe some even approaching 400. But this Rivulet Trail is a place that I'll talk a little more about, but you can go and it's an easy walk. You know, I'm 81 years old, so I'm not spry anymore, jumping through and hopping tall boulders with a single bounce. I'm happy just to put one foot in front of the other. But this is one of those places that we can all go, and maybe we can all go there together sometime, or at least some of us. Anyway, let's go on to the next one. How old do trees get in Massachusetts in these ancient stands? Well, this is a private forest, black gum forest in Orange, Massachusetts. My good buddy Dave Orwig, Dr. Dave, at Harvard Forest cored one of these dinosaur-looking trees at 537 years of age, and that didn't include the amount that it would have grown up to the core height, so it was probably about 500, maybe 550 years old. And that is the oldest tree that we've actually confirmed here in the Bay State. However, this same species we have dated to is actually, the number is now over 700 years old. So the black gum is our oldest hardwood species, hardwood, in the eastern United States. And it's not the oldest species, that would be the bald cypress. But nonetheless, here in Massachusetts, we have trees then, and this virgin black gum swamp dating all the way back to over 500 years. And to me, that's just amazing, because the storybooks didn't say that. Scholars felt that by the middle of the 1800s, Massachusetts by then was about 70% cleared, some places 80%, and even in the Berkshires, over 50%. And whatever was left was assumed to have been at least cut over once. And so these places were not supposed to have existed at all, but there they were, and we still have them. Now, going from just the appearance of a cluttered forest, complex forest, what really, how do we describe more completely the characteristics that we look for in an old growth forest? Well, I've enumerated them on 2 sheets very quickly. They generally, relative to what's around them, are going to have larger trees. Now, that doesn't mean all old growth forests have big trees. Those that are growing in poor areas will have smaller trees, but relative to what otherwise would be there, they have larger trees. The forest floor is often pitted with mounds and pits, and that's where trees have fallen and filled in, and we call that also pillows and cradles. But it gives the forest floor an undulating structure, and this gives us more habitat, places for habitat, particularly after a tree is first blown over and it turns up a big mound. And you can see that in William Cullen Bryant, where if we do that together, so yeah, I can point out where these pits start, pits and mounds start, and how they progress to where 200 years later, it's just a little bump in the forest floor. You're going to see logs in all stages of decay and randomly scattered. That's going to be a distinguishing feature. And by the way, those logs still, although they're decaying, they still hold a lot of carbon. Certainly, there's an abundance of old trees, implied by the name, old growth, old trees, but there's also young trees coming up in gaps. Because you have gaps, we call those tree fall gaps, and they'll be of different sizes, where a tree is blown down, or a tree blows against another tree and several go down, or you have a major wind event, or ice comes along and breaks a lot of crowns and tops. You get, it's a very dynamic system. It's not a stagnant system. And you have simply standing dead snags, particularly if they're conifers, particularly if they're white pines. And that creates a lot of nice habitat for things like woodpeckers. The forest floor is just very, 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 very thick. We call that the duff layer. And it is, the duff layer is built up literally over centuries. The colder the climate, the more the duff, the slower that you get decay. And you get well-developed plant communities of all types. It's not just the existence of a plant, it's the abundance of them. It's a mature plant colony. And you can't have a legitimate old growth forest and have visible signs of human occupation like rock walls and fruit trees and whatnot, and alien species or invasive species. That won't be in a real old growth forest. And these old growth forests are pretty good at holding their own in keeping the invasives out. Of course, some will get in. Forest grown tree shapes. If we should take a walk in the Bryant Woods and look at characteristics that as a tree ages, its shape changes. And, you know, we in our senior years, we don't look like we did when we were 20 years old. And we can tell the difference. Well, you can also tell the difference in trees if you know what to look for. And then in an old growth forest, generally, there will be an abundance of species that prefer or exist in shade. We call them late successional species, so they can grow up in the shade of other trees, and then they tend to create the dominant forest type later on after a couple of 300 years. Going on, there's going to be a large range of lichen and fungi or fungal species. This is where old growth forests are shine. Most people don't really pay any attention to that kind of life, but that's a very important part overall. And going underground, the fungi are extremely important because they create this web of life beneath the ground that feed the trees. So it's very underground. It's a community. Very much, it's not all about competition. It's as much about cooperation, and we could talk a lot about that. That would be a whole lecture in and of itself. Again, the species that you see in an old growth forest will be those that tend to persist in shade, as opposed to those that come in when a forest is first opened up, and we call them pioneer species. But some pioneer species persist for a long time, like white pine. So you can see pioneer species in old growth forest too. And then the last one I'll mention is that it's not, you're not looking like the forest equivalent of chickens in a hen house or a chicken coop. Every chicken looks like the other. It's not a plantation. It's not a garden. There's a structure there. There's layers. There's the ground layer. There's what's on the ground. Then there's the shrub layer. There's the understory layer, and there's the canopy layer, and there's the super canopy layer, and it's all mixed up. There's no clear dividing line. So it's a complex environment. And to emphasize the point of it being complex, let me look at, how am I doing, Monica, on time? Let's look at the next slide. This is a wonderful old growth forest that would impede you if you try to go through it. You are stumbling, and I guarantee you will invent new four-letter words because you're constantly getting up and trying to make just a few yards because everything is gnarled. This is a top of the mountain, Plateau Mountain in the New York Catskills, top of the mountain old growth. And that's what it's going to look like. It gets hammered by ice. It gets wind all the time. It gets a lot of snow. It gets drenched. And as a consequence, everything is filled. Every niche is occupied. You've got a lot of ferns in these forests. And so I emphasize structural complexity. That's really what makes an old growth forest different from a younger and a managed forest. Now let's go next here. In a kind of a summary of values, I would say at the simplest level, biodiversity. You have it above ground, you have it below ground. In years past, a lot of people didn't understand that. And in a lot of the wisdom here in the Northeast was that they thought that an old growth forest really was a botanical desert. It's exactly the opposite. But where did they get that? Well, they were basically looking at hemlock forests, and whether they're young or they're old, they don't have the herbaceous understory because they create a very, excuse me, acid environment. And as a consequence, that suppresses the usual herbs, so you don't get all the spraying wildflowers and that sort of thing. It had nothing to do with it being an old growth forest. It had it to being a hemlock forest. But that's what they thought old growth looked like. And so there, along the way, we had to change our understanding and recognition of what old growth looks like. These old growth ecosystems are resilient. Now you'll hear that talked about a lot. A lot of people today into the management end of it look to manage or create resiliency through management actions. Basically, what that really means is usually you want to perpetuate timber species and have a forest in which you have a viable timber crop in the future, and you've got to make sure it's the right species and you don't have species that are going downhill like American beech and whatnot. So resiliency there really has much more to do with what you're going to do with the forest. But if you just want it to exist and continually evolve, then these old growth forests do that quite well. Genetic pool, yes, this is where it all came from. We don't get the species diversity on the earth from our managed woodlands. We get it from what Mother Nature created over the eons. That genetic pool is in the old growth forests. Next, the greatest amount of carbon storage, both above and below ground. This I could have an entire lecture on, and I do a lot of work with climate scientists now because as an engineer, I measure the trees and we reduce the tree to a carbon statistic, but a more accurate one than doing it through statistical modeling. Our forests, though, are also, if we think about them, links to the past. How am I doing? Go fast. Okay, and looking at the bottom, aesthetic and spiritual, that you get it when you get there, when you're in it. Going forward, where would we see old growth forests in Massachusetts? Well, for us here in the valley, William Cullen Bryant is just it. It's just 20 minutes away. And you get old growth, you get huge white pines. It's a wonderful place. Mohawk Trail State Forest, Charlemont, there you see more of it. You work harder to see it, but you can see most of it, and you can see a wider diversity. Adjoining Mohawk Trail State Forest, Savoy Mountain State Forest, then disjunct up farther to the north is Monroe State Forest. Great old growth there. Mount Greylock State Reservation. You can go over to Ice Glen and walk the Glen. Stockbridge is wonderful. The town loves Ice Glen. They protect it. Melville and other great literary figures of the past, icons, walked Ice Glen, but it was old growth, is old growth. Wachusett Mountain State Reservation, I could have a whole lecture on that alone. Go sometime, go to Gilder Pond and walk the trail around. You're going to go right through old growth forests and trees that I personally dated to 375, 380 years old, hemlocks. And a little tiny bit on Tom State Reservation, as you saw, and even Bullard Woods over at Stockbridge. These are places you could get to and legitimately walk in them. I'll end with a picture from my great friend, art photographer Mitch Epstein, who is specializing now in photographing and bringing the art in the forest out into his great photographs. And this is a 300-year-old yellow birch in Monroe State Forest, and you would walk very close to this one if you walk the trail from the Dunbar Brook Trail. I think that's where I now call for questions.
Before we begin the questions, which we will ask you to put in chat, let me just announce our next two speakers. Our next speaker is on March 3rd. Speakers is Barbara Blumenthal and Ellen Meerpohl, who are going to talk about learning the truths about Northampton State Hospital through fact and fiction. And the following one is April 14th. We've moved it because the usual date would be April 7th, and we've moved it to the 14th because the 7th is Good Friday. And it's going to be Kelsey Flynn, who's going to talk about life in improv, which should be a lot of fun. So now the way we're going to do the Q&A is I have some questions that people sent me before the talk, and we have some questions appearing rapidly in the chat box. So I will read the questions and Bob will answer the questions. You all set, Bob? Ready to go?
Ready to go.
Okay. Let me start with some of the questions from the audience. Kim L asked, what we can do about the state of mass selling rights to lumber in our state forests?
I'm sorry, could you ask that question again?
Yeah, are you having trouble hearing me?
I just missed one or two words. I want to make
sure. What can we do? Well, oops, I just lost the question. Just a second. What can we do about the state of Massachusetts selling rights to lumber in our state forests?
Well,
that's not what you're doing.
This is a little beyond what I actually am involved with. My part of it is as the chair of the Forest Reserve Science Advisory Committee. There's a part of the state forest is set aside. No logging, no commercial activity of any type. And that I try to make sure stays that way as a resource for all of the reasons that I talked about earlier. I'd prefer not to try to get into the other side of it. I have certainly a point of view, but I respectfully would not want to address what they're doing in that part of the forests, state forests, that are open to, and they've been open to it, for decades and decades, commercial logging. If forestry is done right, and they don't start to try to look at it and sell the public on false benefits, then there is a case to be made to have good forestry operations going on those actively managed parts of state land. We, the citizenry, have to make sure that it is good. The forestry procedures and operations are as good as they're described to be. I'll stop it at that.
Thank you. The next question is from Melissa Curtin, and she asked, could you explain a bit more about what structural complexity?
Yes. Over the course of decades to centuries, trees are going to blow down and be in various states of decay. Trees that are standing, some are going to be alive, some are going to be dead. As a tree gets older, its crown will become more complex. You'll get breakage in there. You will have different lichens and fungi that grow on the tree. It will become literally a hotel in the forest. These big trees are that. They're structurally, they're not simple figures, in other words. Every part of an old growth forest has that kind of complexity. It's not about any one part of it. It's the gestalt. It's the whole thing. And it's structurally complex in the sense that you have young trees that are just starting out, filling in gaps where you had a blowdown. You've got older trees that are at the far end of their life. You have young strapping trees. Everything is in a state of change, but creating a very broad set of possibilities. Nature doesn't clean her house like we might our own house. We sweep out the dirt and all that sort of thing. All that piles up, and everything piles up in these old growth forests, and that creates many different habitats. That's structural. And in the processes that go on, some are short term, that they play out in a year or even less than a year. Others go on for literally centuries. It's hard. It's a very complex environment. I hope that, does that answer?
It's a good answer. So I'm going to combine two questions now. One is from, I lost it. Sheila Coy, which is which species do well through climate change and which ones will struggle. And Sarah Backrack, who had asked what are the main kinds of old growth trees in Massachusetts, more related to the first question, what threats, insects, disease, human-made are there for these beautiful trees? So climate and other threats.
Unfortunately, there's a lot. And we bring them in as people. The forest didn't bring in hemlock woolly adelgid. It didn't bring in elongated scale, hemlock elongated scale. It didn't bring in the Asian longhorn beetle. It didn't bring in the emerald ash borer. We can go through a long list of alien species that attack our forests. And as a consequence, we lose species. Now, the older forests, they tend to bounce back. They may not bounce back with the species that we wanted. So in one case, for example, when the hemlock woolly adelgid, which is from Asia, Far East Asia, and China and Korea and Japan, there's not just one adelgid, there's several. When it started spreading, it was brought over here. And of course, people are going to bring stuff into the country, and that's the way it comes in. Well, the hemlocks didn't have any natural immunity to them. So what hemlocks in in the other side of the world could deal with, ours couldn't. We have since found ways of treating the hemlocks. And so rather than this wonderful tree, this wonderful species that most of us really love, going and being lost forever, there are mitigations. In other words, we can treat and stave off some of the loss of some of the species. Some of them, too late, like the American chestnut, but maybe it will come back eventually in numbers. Of course, there are hybrids now with Chinese chestnut that in fact do survive the chestnut blight. But to make a long story short, there are no guarantees that any species that we have is not going to be struggling with climate change. One of the good parts of the forest research is to try to find which species are most resilient and able to withstand whatever the climate change. That's not taken place yet. That's a lot of talking points. We're trying to find out what that is. In the meantime, we're going to see changes continue in these older forests, but they still have a resilience about them that I think gives them some protection.
Thank you. So here's another question. I think this is from Nina Kleinberg. What kind of forest husbandry did the indigenous population engage in before 1492?
Well, indigenous populations spanned a lot of different social structures. In the Northeast, particularly when you get into Vermont in the colder climates, it was much more of a hunter-gatherer kind of society. So you wouldn't be able to tie them so closely to individual tree species. They used a lot of them. For instance, if we take the white pine, that is the Iroquois tree of peace. 5 needles, 5 original tribes of the Iroquois Confederacy. You could strip off the outer bark and take the inner bark and use them as noodles. You can use hemlock needles. It's got plenty of vitamin C. There's always been uses for trees across the climate types that Native Americans would make use of. In the central latitudes, over in Ohio and whatnot, they often attempted to keep the woods more oak or oak and hickory. Those were nut-bearing trees. So where you had that as the capability, they made great use of them. They made great use of nut-bearing trees or acorn-bearing trees, whatnot, here in the Northeast. But it's not just one story. It's a really broad range in which different tribes made different uses of different species to different degrees. And the idea that the Native Americans manage the forest like we do, that's just stupid, people. That's just plain poppycock. That's somebody justifying what they want to do today and laying it on as though the Native Americans were routinely burning everything else. They were not. Harvard Forest did an excellent study, I don't know, it's been a couple of decades ago, I guess, in which they went to a lot of the parts of the Northeast in Massachusetts, central Massachusetts, and did a lot of pollen grain analysis to test the idea that all of these forests had lots of carbon in them. So, that would have been suggestive of routine burning. They didn't find it. On the other hand, if you went into the river valleys, oh yes, Native Americans managed along the areas where they lived, they managed quite a bit. And you would have had much more established Native American culture, for example, here in the Connecticut River Valley, Well, that makes sense. You have the water, you have the fish, habitat, etc. But it's not just one story.
What a great answer. Okay, so here's another question. Can you comment on efforts to reintroduce the American chestnut?
I have had over years a number of friends that have been involved in that. I'm not an expert. I know that they have made a lot of headway, even to the point that there have been actually some resistant original American chestnuts discovered. And sometimes we think we've discovered them and turn out to be not an American chestnut. And by the way, American chestnut was taken all the way to the West Coast. There's American chestnuts that are real original American chestnuts in Oregon and Washington and that sort of thing. But there is, I think, still an active ongoing program that will, to my, what I would say is it's going to happen. We're going to get the chestnut back as a hybrid to some degree. But bear in mind, the American chestnut was not as widespread as a lot of people have been led to believe. And I'll read that, oh, every other tree up here in the Northeast was American chestnut. That was not true at all. Pollen grain analysis and whatnot, and even people who originally were, they did tree surveys for the communities, witness trees. They gave us pretty much a good picture, and there were plenty of chestnuts, but a lot of the chestnut sprouting came on, and it's a prolific sprouter. So if you cut them, you're going to get multiple stems coming back, and they come back all over the place. That actually happened, in particular in Connecticut, whatnot. That was as a consequence of the original forest being taken out. Chestnut was there, but it wasn't every other tree. Maybe that's more information than you asked for.
Not at all. I have another question. I have a question, which is, how can we join in tours of these trees? And do you still take people on tours, or do you have suggestions for how we might do it?
I'm going to turn this over to my manager. I don't do sweetie pie giving the thumbs up, because she kind of watches out for my health and everything. I would love to take organize 1 or 2 trips to the Bryant Woods for my Northampton neighbors. But sweetie pie, will you come rescue me?
Okay, we talked about this, and we'd love to do that. If he does something, it will be when the weather's a little warmer, and as long as we're sure that his knees are working well enough. If we do a tour, we want only 15 people at a time. So Bob said he would be willing to do maybe 2 walks with 15 people each. If there are too many people, it doesn't work, we found. So that could be arranged through somebody in Northampton Neighbors. But we probably want to wait till the weather is better. But he can certainly do the Bryant Woods through the old growth walk. And depending on what he feels like, going through the big pines may be too much, too long. I guess it's about a mile, right?
Yeah.
Yeah, so that's that. I think that he has agreed to do some kind of a walk sponsored by Kestrel Land Trust in April?
June, I think.
Or June. So if you are connected with Kestrel Land Trust, you will hear about that. And again, if you want to go, you better sign up right away, because there again will be a limit. And speaking of Kestrel Land Trust, there is a Kestrel Land Trust now, the Monica and Bob Leverett Forever Wild Fund, which is our attempt to create an opportunity to make more old growth for the state of Massachusetts.
Thank you.
That's fabulous. So here's what I'd say. Let us know when you might be able to do some tours, and we'll advertise and let people get in and get waiting lists and whatever else you need for us to do. That's exciting.
I feel a special kinship to Northampton and absolutely Northampton neighbors. So this is something I love to do.
So exciting. Okay, well, we talked to Bob before the beginning of the talk and asked him if he would go over 4 o'clock if there were any more questions. And there are more questions. So here's what we're going to do. We're going to put up our thing about Northampton neighbors so people can see where the web page is and see how to do things. And then we'll go back to questions. That'll take a minute. Let me just ask one last question because we're not quite at 4. I thought this one wouldn't take a whole lot of time. It's from Janet Nelson, and this is before we go on to the last list. And the question is, where can we get your great cap?
Well, this is American Forests. I'm the senior advisor to the Champion Tree Program because I wrote the manual for measuring trees. When I started with them, they had 3 pages on the internet, how to measure a tree for championship status. One measurement for taking circumference, one for the tree height, and one for the crown spread. And when I got through with it in my engineering fashion, it was 86 pages long. They hate me. I took fun out of it, but they gave me a cap.
So if you write an 80-some page booklet, you can probably get a cap too. All right, we're going to put up our Nina. Are you around? Yeah. And then we're going to go back to the questions. It's a good time. If you need to leave, we understand. Now's a good time to do it. And then we'll come back and ask a few more questions. And here is, please join, donate, volunteer. We survive by volunteers, giving and getting. Please ask us for services and please donate. That we're completely free. We have one executive director and she has one person that works with her, which is brand new. We're all volunteers and we would love you to volunteer to get and give. Let me just leave this up a minute so you can see our website and our number. And Diane Porcella is our wonderful executive director. And she's the person you're likely to contact if you go through info@northamptonneighbors.org. And Sue Hawes recently joined her, who's on the screen right now. Is everybody ready to go back to questions? Go like that or something if you are. Yes? Okay. So, there's Diane in the yellow hat. Okay, so can you see, Jacqueline said, I believe some folks believe that older trees stop sequestering carbon effectively. Is that true or false?
Oh boy, there's a book. I do modeling from seedling to sapling to pole size to young mature to middle mature to old growth. Trees, let's say, that are long-lived, like a white pine that can 250, 350 years, it is really sequestering a lot more carbon when it's 100 years old than it was when it was 30. Somewhere between 150 and maybe 200, it's going to start going downhill, but it will still be sequestering carbon as long as it's in good shape. Of course, if the tree is dying, that's a wholly different situation. That's one species. I can take sugar maple, take yellow birch, and take white ash. Every one of these has a curve that it goes through. To generalize and say young trees sequester more carbon than old trees is not an accurate statement at all. At some point, yes, they do. The question is, when does that occur? It occurs later than a lot of people might call young. I mean, I don't know, if you think of 100 years old as young, then young trees sequester a lot of carbon. But the point being, it's a little like this. Let's say you got a dollar and you put it in the bank and you got 100% interest on it. In a year, you got a whole $2. Wow, you're rich, huh? Well, but you had 100% interest rate. Now, it's the same kind of argument when you go to a young tree. It is growing fast. It is gaining volume as a high percentage, but it's still a very small plant. So the actual amount of carbon that it is added in a year is very small up for the first 25, 30, 35 years. Then it starts to take off. And that's the cause. So a lot of what I do are the mathematical analysis of the curves of where but in general, for the species that we commonly see around the neighborhood in the northern red oaks and whatnot, at 100 years, they are still sequestering carbon at a very high rate. Now, here's the point. If you looked at a cross section of a young tree, it might have a growth ring that was 1/3 of an inch wide, fast growth, but it would, let's say, be 1/3 of an inch on a diameter of 4.5 or 5 inches. The actual amount of wood, the cross-sectional area of wood, would be much smaller than 1/10 of an inch wide growth ring on a tree that's 3 feet wide. You will notice the growth on the young tree. It starts out as a seedling, now it's up to your shoulders, it's above your head. That looks like it's really booking. You won't notice that 1/10 inch growth ring on that large tree or that extra growth in the crown. Guarantee you won't notice it at all. It looks like it's stagnant. And from a pure timber standpoint, adding 1/10 of an inch ring on a big tree, commercially, it's pretty well stagnant, dormant, senescent, but not biologically.
Before I ask you another question, some of you might have seen that Diane Porcella, in her typical efficient way, posted on chat saying, if you're interested in walking with Bob, please add your email to this chat. Then fingers, branches crossed, it works out. We'll let you know first. So this is a good way to start it going. I'm sure we'll ask you again, but this is a great way. Just put it in chat and hit enter. Okay. And people ask where we can get copies of these lists and presentation. They're all going to be this evening or tomorrow on YouTube. You can go to our website, go to the YouTube, or just go to your search engine, type in YouTube and Northampton Neighbors and Bob Leverett, and you'll probably find it. And you'll get all the lists that he put up. I think we didn't answer this one. Sarah Lennox asked, can you comment on the new commercial forestry efforts to selectively cut to preserve old growth forests and biodiversity?
Oh boy, that's another 2-hour lecture.
We got to have you back.
No, you don't actually cut trees in order to preserve old growth. Those who present it to the public that way are not saying it right. If what you're trying to do is preserve some old growth characteristics while also treating a stand of trees commercially, I mean, you're harvesting them, you're sending the wood wherever to Canada or wherever, it's a commercial economic operation, then there's some things you can do to not turn the forest into something that is totally human, generated, looks like a plantation or whatever. And from that standpoint, you can speed some characteristics along that would ensure, for example, after you've taken out the most valuable trees, by the way, then you can take a tree and knock a hole in it so that woodpeckers will get there. You can recreate some of the habitat that would be associated with an old growth forest. But folks, it's not an old growth forest. If we were being dealt with honestly, they would explain why they're doing what they're doing. And it may be for a very good cause. They may want, in other words, to preserve a lot of the forest processes that go with greater age or longevity, or a forest that's evolved over 300, 400, 1,000 years. They may want some of those processes to be sped along after they have done a major timbering operation. But that doesn't create an old growth forest. You can't create a 300-year-old tree by taking a younger tree and knocking a hole in it and expecting it to behave like it had seen 300 winters and develop the lichens, the algae, all of the different plant communities, the animal communities that are associated. You know, it's easiest to understand this through the really great trees of the Pacific Northwest. When my friends Steve Sillett and Bob Van Pelt, the great redwood researchers, climbed up into that upper canopy, they found species that were endemic to the upper canopies, the canopies of redwoods and sequoias and Doug firs and Sitka spruces and whatnot that were nowhere else. Now, you're not going to get that by trying to speed a process along that really took several millennia. And so I'm not against what they're trying to do when they're trying to, in part, compensate for what they took away from the forest. But let's not portray it as being an old growth forest, or if they're creating designer old growth. Baloney.
This next question is sort of related. It's from Jonathan Dean. Around my house is a second growth forest of white pine, hemlock, and white oak. We are losing white pines. What should we plant in their place?
I'm sorry, the white pine is going, and he wants to replace that.
That's what he says. We are losing white pine. What should we plant in their place?
What I would want to, I guess I'd want to talk to him about what does he want to see as an outcome? Does he want to see certain species there that he likes? Perfectly legitimate, his land. Does he want to replace what is going, in other words, create little openings and plant white pine seedlings, so you're getting white pine coming back as a second generation, or what? Is he looking for a commercial possible species? Northern red oaks, that's always a good one. You could be doing it for a lot of different reasons. I'd want to know what the objective was. I don't mean to not answer the question, but I could answer it in a lot of different ways.
Okay, so here's another question. Are coniferous mountaintops, such as those in the White Mountains, considered old growth? How old might those dwarf trees be?
Some do consider them old growth and some don't. I do. The Krumholz area, oftentimes the individual trees, Krumholz, they're not maybe all that old, but the root systems are. They keep coming back up. So it's an old growth environment, although the individual species that are growing there in replanting season may not be that old. I think that the upper elevations, the White Mountains, are very much, you can accept them as the equivalent of an old growth community with alpine furnishings. But by the way, you know, years ago, I was up on the top in Nancy Brook wilderness, Pimagit-Wasset Wilderness area. And it was a front page story on the Boston Globe. And I still probably had more of my Southern accent then than I do now. And if those of you who hear it, sometimes people will say, well, where are you from, Bob? And I like to say, well, I'm from Southern Northampton. I grew up in the Southern mountains and had an accent that you could cut with a slice with a knife, and the U.S. Air Force beat most of it out of me. I think as a young officer at the Ellsworth Air Force Base in South Dakota, I was too young to be the commander of an engineering team, so they brought in a senior officer, and he was from Brooklyn. Became a great friend of mine and a business partner later on. And he went home that night and told his wife after we had talked and met, he said, I have met Jubilation T. Cornpone. And so I learned that, okay, this is who I am. and I have not had any problem getting along up here. I love Northampton. And the environment that we have here in Northampton is rich with the education. It's just a great place altogether. So I feel so privileged to be here, and thank you all for, letting me talk.
I think that we've covered most of the questions. I've tried to combine some with one another. I think you've spent a lot of time with us, so I don't want to wear you out too much, especially since we're going to walk with you. There are already a lot of people who put their names down for a tour with you, and we'll collect those. We want to thank you. This was wonderful, just as we expected, or more than we expected. And I wish we could clap, but thank you so much, dear neighbor Bob Leverett.
Thank you all so much. Love you all.